So let's try another example. It is a program to print natural numbers from 1 to n. If n is 10, then it will print from 1 to 10. And if n is 100, then it will print from 1 to 100. So let's try to calculate the time complexity of this code. Here, 1 unit is needed for assigning 5 into n. Next, we have a for loop instruction here. And this loop is created for printing 1 up to n values. And this line will take n plus 1 time. So now question is, how we can say that this line will take n plus 1 time. So let's try to explain. Here initially I is 1 and the loop will continue as much as it meets the condition. Okay, to take a look on this table, it will help us to understand how many times the loop will execute. So initially I is 1 and n is 5 and it meets the condition. So as it meets the condition, it will go inside the loop and it will print 1. After printing 1, it will increment the I by 1 as we have I plus plus here. So now I is 2 and it again meets the condition. So now it will go inside the loop and it will print 2. In the same way, it will print 3, 4 and 5. After that, the I will be incremented again. So now I is 6. But it is unable to meet the condition here as 6 is greater than 5. So the program will not able to go inside the for loop and come to return 0. So how many times this for loop is executed? The answer is 6 and our n is 5. So we can write it as n plus 1, that is 5 plus 1 is equal to 6. That is the number of execution of this line. So we can say that this line will take n plus 1 time. So let's come to the next line. The next line will take n time as our loop will check the condition for 6 times, but it will able to go inside the loop 5 times. That is 1 time less from the for loop line. Okay, that means this line will execute for n time. And finally, this line will take 1 unit of time. So now add up all the values and we will get this equation, that is 2n plus 3. Now we have to find the time complexity from this time equation. So here we have our equation. So first work is select the fastest growing term. So here our fastest growing term is 2n. So now find out the coefficient and remove it. So after eliminating the coefficient, we have n. So the time complexity of this equation is O of n. This O of n is known as linear time. Linear time complexity means that as n grows, the runtime of the algorithm will also grow at the same rate. So let's try another example with nested row. It is a program to print rectangle star pattern. If n is 5, then it will print 5 by 5 matrix of star, and if input is 10, then it will print 10 by 10 matrix of star. So let's try to calculate the time complexity of this code. So here 1 unit is needed for assigning 5 into n, and then we have a for loop instruction here. As I is 1 and the loop will continue as much as it meets the condition. That means I is less than or equal to n. So from the previous example, we can say that this line will take n plus 1 time, and whatever instruction are inside the loop will execute for n time. So initially write n for all the instruction inside the loop. So we have 3 instructions inside this for loop. Okay, now come to the next for loop instruction. So here j starts from 1 and the condition is j must be less or equal to n. So for this line, the time will be n plus 1, and whatever instructions are inside this loop will take n time. So we can write here n. So now come to the last line. This line will take 1 unit of time. So now add up all the time and you will get an equation. So here our equation is 3 plus 3n plus 2n square. Now we have to find the time complexity from this equation. So here is our equation. So now first work is select the fastest growing term. So here fastest growing term is 2n square. So now find out the coefficient and eliminate it. So after eliminating the coefficient we have n square. So the time complexity of this code is O of n square.